Welcome to Shifting Grades. Kindly subscribe to my channel and share our link with your different friends. We are beginning a Form 3 topic, mathematics, called approximations and errors. I would like, first of all, we know what approximations are and what errors are before we continue very much. I know they are not new words, but we can familiarize with them. An approximation is a value stated which is different but very close to the actual value of a given quantity. So if, for example, we say that the length of this classroom is 20 meters, but in actual sense, we measure and later realize that it is 19.7 meters. So you realize the value we had stated is not the exact value we realize after measurement. And therefore, this value, which is just close to the actual value. So if this is the actual value or actual quantity, you find the value which had been stated very close but different from the actual value. We call it an approximate. This is an approximate value. Some other times it's called estimate. It's an estimate. So say you have approximated or estimated. Therefore now you find there is now that difference which is between the actual value and the approximated value, and such is called an error. So an error is the difference between the actual value and the estimated value, or the estimate, which is also called the approximate value. Therefore, when you make an approximation or when you estimate, you find that the estimated value you record will be differing with the actual value, and that difference between an actual value and the estimated value is called an error. We say you have made an error. So when you tell us that your weight is 47 kilograms and in real sense you are 53 kilograms or you are 9 kilograms, then that difference between 49, the actual weight you have, and 47, the weight you have approximated, 2 kilograms, we say this one is an error. You have made an error of 2 kilograms. Therefore, the difference between actual value and the estimated value is what we are calling an approximation. Now, we have seen what an error is. Difference between actual value and approximated value. So I would like us to check different types of errors, whereby we will start with round of errors. Round of errors. We have truncation errors. We have the absolute error. Absolute error. We have the relative error, and lastly we have the percentage error. The percentage error. For these last three, they can be errors due to a measurement recorded or an operation which has been done on given quantities. Therefore, we'll be seeing them deeper in the next lesson. But meanwhile, we'll be seeing what they are. So we can start with a round of errors. Round of errors. So when we are rounding off, we make mistakes. Round of errors. Round of error, in other words. Therefore, when we are rounding off, we record a value which is not exact. And that difference between the rounded off value and the exact value is what we call an error. Therefore, we can say this is the error incurred during round off, or due to round off, due to rounding off of values. Therefore, if I tell you that the actual or the real height of a tree is 10.26 meters. Find the error when the height is rounded off to 1 decimal place. To 1 decimal place. The height of a tree is 10, then it is rounded off to 1 decimal place. Find the error. Find the error. Solution. So in this case, we got actual height as 10.26 to 1 decimal place, which is now the estimated value now. It will be 10 point, the first decimal place, then we consider the second digit, it's a 6. Therefore, a 6 is above 5 and can increase to 3. Therefore, the rounded off value to 1 decimal place is 10.3 meters. Therefore, now with this, we can say because this is the estimated value and this is the actual value, then the error in this case, when we take 10.26 minus 10, this is giving us 10.26 minus 10.3, negative 0.04. Therefore, the error is just the absolute value of this 0.04. It's good to note that when we are talking of an error, we just get the absolute value between actual value and estimated value, because some other times the estimated value can be above the actual value, some other times below. So if I say, for example, the population of Kenya is 47 million. This is an approximate I have made, but on the ground you may find things are different. In the process, some children are getting born, babies, and the population might be 47,671,286 people in Kenya. Therefore, this is an approximate I have made, but on the ground, the population is this one. Meaning that now, when we take the actual value and we subtract the approximate I have made, we will get a positive error, a positive number. So that will be the error. On other terms, I may argue that the population of a school like Mukaga's is 600 students. But on the ground, you realize there are 596 students. Therefore, in this case, I have approximated 600. Of students is 596. Therefore, in this case, when we take the number of students, the real number, minus the approximated value, we will get a -4. So my error, I will not write it as a -4. I got an error of 4. So we just take the absolute value, even if sometimes it's a negative. We just extract the absolute value between actual value and estimated value. The other error, I'll be mentioning truncation error. Truncation error. Truncation error. Truncation error. Truncation error is the error incurred when a value is truncated. It's something close to rounding off, but a bit different, because if, for example, you are given 11.38 and you are told to truncate to 1 decimal place, you just write 11.3 after 1 decimal place. You don't consider the value which is on your right. So on truncation, we just cut. If it's 11.38 and we are truncating to 1 decimal place, so the first decimal place is here, we just write the value the way it is, without considering whether a 8 can increase this one to 4 or not. We don't consider it. We just write 11.3. So this is what we call truncating. If you are told truncate 9.68 to the nearest whole number, so we will just consider 9, and whether this is a 6 which can increase the 9 to a 10 or not, we just record the 9 the way it is, without considering the values on the right. Therefore, that's what we call truncation. For example, you can be told 36.486 is truncated to 2 decimal places. Find the error, or the truncation error. Find the error in the truncation of 36.486 to 2 decimal places. Therefore, you come here and say the actual value is 36.486. Then the truncated value, or the estimate now in this case, will be 36.48. We don't consider the other number, whether it's something above 5 or not. We just omit it completely. Therefore, to 2 decimal places truncated, it should be this. Now you find that the estimated value, or the truncated value, and the actual value are different. And that difference between truncated value and the actual value is what truncation error. Therefore, the truncation error in this case will be 36 dot minus 36.48, giving us 0.006. 0.006. So that is the truncation error. That's what we call truncation. Therefore, now I would like to discuss what we are calling absolute error, relative error, and percentage error. Therefore, we say we have now absolute, relative, and percentage error. And percentage errors. I would like to handle the 3 of them. Let go. And I'll start by recording them. they might be from a recorded value or measurement, and in the other case they might be in when a computation has been carried out now on a measurement. So we can say propagation of errors. So we will see them again under propagation of errors, whereby we will see now when values have been added, subtracted, divided or multiplied, the errors, the three of them. But now we start by saying them when a value has been recorded. Therefore we start from measurements. So we know that measurements depend on the accuracy of the machine or the instrument taking the measurement. Therefore, if you given, for example, something which has been recorded into the nearest whole number, we say that the accuracy of that machine is 1. So when I tell you that the age of Jane is 22 years, this has been recorded to the nearest whole number, and therefore the accuracy is 1 in this case. When I tell you again, the height of James is 1.7 meters. This has been recorded to an accuracy of 1 decimal place, and we say it has an accuracy of 0.1. It is recorded to an accuracy of 0.1. When we say the radius of a ball bearing recorded by a vernier calipers is 3.62 centimeters. The radius of a ball bearing from a vernier calipers is recorded as this. So this one has been recorded to an accuracy of 2 decimal places, and we say that it is to an accuracy of 0.01. Therefore now, there is what we call a absolute error. Absolute error is when the accuracy into which a given measurement has been recorded is divided by 2. So the accuracy, the degree of accuracy, the degree of accuracy, when it has been divided by 2, we say that that's the absolute error. E.g., finds the absolute error in 12.3. In this case, solution, 12.3 has been recorded to 1 decimal place, and therefore the accuracy is 0.1 because it is to 1 decimal place. Therefore, absolute error will be 0.1 divided by 2, 0.05, sorry. So the absolute error when the measurement is recorded in 1 decimal place is 0.05. Another example, when I tell you find the absolute error in 22.24. This one has been recorded to 2 decimal places. Therefore, to an accuracy degree of 2 decimal places, then it means this is an accuracy of 0.01. And therefore, to get absolute error, we will have to get this degree of accuracy and we divide it by 2, which will be 0.005. Therefore, the level of accuracy determines the absolute error in a given measurement. I'd like also to mention so it's good to master that when a given value is recorded to the nearest whole number, then we say it is up to a degree of accuracy of 1, and its absolute error is when we take 1 and divide by 2, which is half or 0.5, when it is to a whole number. 1 decimal place, 0.1, we divide it by 2. We get the relative error in that measurement. 2 decimal places, 0.01. We divide by 2. We get 0.005. And such, and such. Therefore, you realize later that the more the number of decimal place, the more the accurate the instrument, and we say that the more reliable the instrument is, and the less the error made in recording such a measurement. It is also good to master that something called the relative error is just a fraction of absolute error when we divide it with the recorded value. Absolute error divided by the recorded value, we call it relative error. Let me give an example. E.g., the mass of a bag of maize is 98.2 kilograms. Find the relative error. Find relative error. Solution. We will start by first of all getting the absolute error, whereby we will say 98.2 has been recorded to 1 decimal place, and therefore the degree of accuracy in the instrument which measured the 98.2, the degree of accuracy is 0.1. Therefore, if this is the degree of accuracy, 0.1 due to the 1 decimal place, then you say absolute error is given by 0.1 divided by 2, which is 0.05. Therefore, if absolute error is 0.5, then the relative error of that mass will be absolute error divided by the recorded value, which will be 0.05 divided by 98.2. This is giving me 0.0005092. So this is what we call the relative error. The relative error. In another case, now we may have what we're calling percentage error. And percentage error is given by relative error multiplied by 100%. So that's what you call the percentage error. Let me give an example asking on percentage errors. Percentage errors. You can be told, for example, the length of a field is 100.2 meters. Find the percentage error. Find the percentage error. Find the percentage error. Therefore, in this case, the recorded value is 100.2 meters, meaning that it has been recorded to an accuracy degree of 1 decimal place, and hence the absolute error. Because accuracy is to 0.1, then absolute error will divide the accuracy degree by 2. This will give us 0.05. So now, for us to get the relative error, in this case, we need to get the absolute error, and we divide it with the recorded value, which will be 0.05 divided by 100.2. This is giving us 0.00499. Therefore, this is the relative error. Now, to get percentage error, we get absolute error and we multiply with 100, and this will give us 0.0499. We record it as a percent. So percentage error, relative error, has been multiplied by 100. That's what we call the percentage error. Before we wait for propagation of errors, I would like to mention something to do with limits or the range of a given measurement. The range of a given measurement. Range, or you can say the limits of a given measurement. The limits of a given measurement. So to get the limits of a given measurement, or where a measurement lies, we take the measurement, then we add or subtract the absolute error. Add or subtract the absolute error in the recording of the given measurement. Therefore, we subtract the absolute error to get the lower limit, and we add the absolute error to the measurement to get the upper limit of the given measurement. Let me give an example to this. Find the limits of 10 meters length. So 10 meters length, what will be its limits? In this case, we say accuracy is to nearest whole number, meaning that then the degree of accuracy is 1. So absolute error, the level of accuracy is 1 because it has been recorded to the nearest whole number, but now we divide it by 2 to get the absolute error. Degree of accuracy, because of nearest whole number, it is 1. We divide by 2 to get absolute error, 0.5. Therefore, to get the limits, then we will say it will be the recorded value 10 plus and minus 0.5. Therefore, a length of 10 lies between, when we subtract, it will be 9.5 to, when we add, it will be 10.5. Therefore, this is the lower limit, this is the upper limit for this length. Again, we can check the limits of, find the limits. When you're given something like 12.3 kilograms. So in this case, it has been recorded to the nearest 1 decimal place. Therefore, to get absolute error, it means we take 0.1, which is the accuracy degree for the recording of that measurement, and we divide it by 2. This will give us 0.05. So this is the absolute error. Now to get the limits of 13 or 12.3, sorry, it will lie between when we add and when we subtract 0.05. Therefore, the limits will be 12.25 to the upper limit of 12.35. Therefore, this is the range or the limits for the height or for the mass of 12.3 kilograms. So that's all to do with the errors and the limits. In the next class, I'll be discussing the same errors, but now when an operation or some operations have been carried out on given measurements. So thank you for following. We shall meet for the next lesson soon. Share our link, subscribe to Shifting Grades. Thank you.